Dito ba tayo natapos last time? Kakaalala ko, no? Tama ba? Tapos na 7:51. Sige. So, dito tayo natapos last time kasi previous slide, scattering. Tama. Okay. Okay, for a review, no? So, ano ba yung mga napag-usapan natin last meeting? So, may I ask, wait lang. Ang date ngayon. 500, 300. Okay. Oh, dami na pala. Sige, si Benji. Andito na ba si Benji? Ayan. Sige, ano yung mga napag-usapan natin last time? Sige. If you have an idea, you want to share? Benji? Okay. Wala. Sige. Si Carla. Andito ba si Carla? Ay, ayaw din. Sige. Okay. So, no one wants to share. Sige, balikan na lang. Hello, naririnig niyo pa ba ako?
Sir, ako na lang po, sir.
Ayan, sino yan? Si Arwil. Sige, Arwil.
Ano
Ayan.
po?
Ah,
Hindi ko po sure kung naano siya, pero ko natatandaan ko po may part po. Yung sa about po sa X-ray diffraction po.
okay.
Mag-share lang po ko kung ano yung naintindihan ko.
Sige lang.
So, yun nga po. Yung X-ray diffraction po, syempre gumagana siya, makikita natin siya yung concept niya through X-ray diffraction machine. So, unang-una is para saan ba yung XDR machine? So, ginagamit siya
XRD.
for material classification. So, ayan na. For example po, meron tayong source, tapos sample, and then detector. Yung source po na yun is composed of X-ray tubes na dun po based sa nabasa ko is nagko-contain po siya ng electrons. So, ano po yung essence ng electrons na yun? Kasi po, di ba, in related po sa Bragg's law din po siya. Kapag po kasi nirelease yung electrons na yun dun po sa yun dun po sa sample, for example po yung crystal po. Yung electrons ng crystal ay parang mabobombard out po, ganun. Yung, kaya po, need niya po mag-release ng energy para ma-fill up yung parang related po siya sa energy shells, ganun eh. From high energy shells to low energy shells. Parang kailangan po ma-fill up po yun. So, need mag-release ng energy. Eh, yung energy po na kailangang i-release ay hindi po siya pwede in form of heat and other energy. So, para po ma-release yun is through X-ray form din po. Tapos ayun po, parang yung term po ata ay, ano ba yung term? Basta po may term po din sa dalawa pong X-ray na nire-release eh. Nakalimutan ko lang po. Tapos, yun nga po, yun ang yung tatandaan ko.
Ano yan? Primary scattered electrons and back scattered electrons.
Yun po ata. Yun po ata. Basta po, yun. Tapos po, ayun din po, may certain wave din po doon na sinasabi po is nag interact po sa isa't isa to produce to produce wave interference po. Tapos yung wave interference po na yun can be classified into two, which is destructive po yung isa, tapos yung isa naman po constructive. Constructive po kapag po ginamitan po siya ng parang light intensity, pag meron pong increase in light intensity, kaya po intensive na dun po nagkakaroon ng constructive wave. Tapos yung isa naman po, destructive po, kapag po less yung signal or reduce yung signal.
Okay.
Tapos ayun po pala sir, yung kanina, yung two types ng wave ay basta nakalimutan na talaga, hindi no pumasok.
Mhm.
Tapos po, ay ayun sir, hindi pala siya two types ng wave, parang two types of rays po pala siya. Which is yung
Mhm.
una, pag nirelease po, yung incident rays, tapos kapag nag-defract na po siya, ay parang nag-bounce po, doon na po yung scattered rays. Tapos ayun po, sinasabi po na no change in energy po doon. Tapos doon po makikita yung concept ng elastic scattering. Yung elastic scattering po, yun po yung sinasabi na no change in incident rays, no change in energy of incident rays at saka scattered rays. Yun lang po.
Okay.
Salamat.
Yeah, very good ano. So nagbasa talaga siya. Okay. More than what was covered. Okay. Others, anyone who would like to share pa kung ano yung nabasa nila? Okay.
Sir,
Okay, Meryl Lou.
ano po, yung pinaka-first po na diniscuss, yung sa Maxwell equation.
Okay.
Lang po. Meron po
Apo.
tayong, meron po tayong apat na equation. Maxwell's equation, ito po yung conservation of energy, conservation of linear momentum, conservation of angular momentum, and conservation of charge po. So, ito pong equation na po na ito ay pinapakita po dito yung ah in, description ng yung complete description ng production and interrelation po ng electric and magnetic fields ayon po kay James Clerkwell. Tapos dito po sa conservation of energy, una po, yung electric field diverges from electric charge po.
Mhm.
Tapos yung pangalawa po, wala po siyang isolated magnetic poles.
Okay.
Pero may tinatawag po tayong Coulomb force na yun po yung nag-a-act between po dun sa poles ng magnet. Tapos sa pangatlo naman, yung yung electric fields po ay napoproduce sa pamamagitan po ng pag-change ng magnetic field sa
Mhm.
pamamagitan po ng Faraday's law of induction. Tapos yung sa huli po, yung conservation of charge. Yung circulating magnetic fields napoproduce po siya sa pamamagitan ng changing electric fields and electric current and electric currents po. Yun po,
Okay.
yun po yung sa Maxwell's extension of Ampere's law.
Okay. Okay. Very good ano. So, ayun na-discuss din natin nung last meeting yung for fundamental classical na conservation laws, 'di ba? And in addition to that, no, sabi natin kung meron na tayong classical laws, no, in mechanics gaya nga ng conservation of energy and momentum, no. Sa charge naman or sa electricity and magnetism, no, meron tayong Maxwell's equation. So yun nga yung apat na yon, no. So from there, from Maxwell's equation, makikita natin na ang light ay mayroong wave nature. Pero more than that, no? So on the main topic of our lecture, last meeting, we have discussed that even though Maxwell's equation appear to be right, there are still other experiments which make, no, light, no, be treated as a particle. So any others who would like to share? So kahit isa na lang. So wala na. So okay. So yeah, we have discussed, no, several experiments already. Okay? And lang. Okay. Ang last natin ay dito sa scattering, no? Compton scattering, which ang kailangan niya lang tandaan ay ito. Ayan, no? So yung initial and final wavelengths, no? So yung ibig sabihin ito ay difference, no? In the wavelength. It's equal to the Compton wavelength times 1 minus cosine theta. Theta being the angle by which, ano, ito siya. By which the photon, no, is moved, no? So kung gaano ka layo, no, yung angle na nagbago sa photon. Okay? Okay. So, okay. So for comparison, no, ng photoelectric and Compton effect, sabi natin, okay, they both treat the light, no, light waves, no, quote unquote, light waves as particles, no. So dito, the photoelectric effect, no, yung energy yung nagmamatter, no, because with enough energy, we can knock off electrons from the surface of a metal, no. So yun, by getting the right work function and the energy which is proportional not to the intensity of the light but rather on the frequency, no, of light. So dito naman sa Compton effect, no, so the momentum, no, is quantized like the energy. So when photon hits an electron or a particle, no, gets it gets bombarded and a different, no, wavelength, no, is being scattered. Okay, next. So the energy photon is mahina lang, no? In it is in the range, no, of electron volts, no? While the Compton effect is in the range of kilo electron volts, no? So times 1000. So photoelectric effect is more pronounced on longer wavelengths, while Compton effect, no, is more pronounced on shorter wavelengths. Okay? So and other principles are for photoelectric effect, no? So electrons are ejected, no, by the incident photons, no? So ejected, no, from the metal surface. Sa Compton effect naman, electrons are excited, no, by incident photon. Kaya yung electrons ay nagkakaroon ng its own kinetic energy leading to the change in the wavelength. Okay? So photons are absorbed in the material, no, for the photoelectric effect. No, they are being absorbed as an excess energy, no, for them to be for the electrons to be knocked off. So here the photon's energy is reduced. That's why, no, the scattered wavelength is always longer, no, so than the incident wavelength of the photon. Dahil longer wavelength, ibig sabihin higher wavelength, lower frequency, lower energy. Okay? So, yun lang po. So next is pair production. So ano ba yung pair sa pair production? So this involves, no, three types, no, of conservation laws, no. So the conservation of charge, energy, and momentum. Okay? Pair production is the creation, no, of an elementary particle. So do you have an idea what an elementary particle is? A particle and its anti-particle. So an example of this is an electron and a positron. So it means that an antiparticle is a particle which is opposite in charge but similar in mass. No? So proton and electron are not antiparticles even though they are different in the magnitude of their charges because proton is essentially heavier. No? So 1,000 times heavier. No? Hindi lang. No? Okay. So next, no? So the minimum, no, photon energy required to produce an electron and positron is equal to the sum, no, of the energies, no, of the electron and positron. No? So, sa pair production, no? Pwedeng mangyari na from a single photon, no? Ano mangyayari? A single photon could have a particle and an antiparticle. So, and you sum, no? Their charges, no? Zero pa rin naman, no? So, kaya still possible. Okay. So, the energy of a photon is equal to okay. Is equal to the energy, no, of the electron, okay, mc squared plus, no? So, mc squared of the positron. So, dahil pareho naman sila ng mass, no? Essentially, pareho din sila ng sagot dito, no? So, wala namang mass na negative, no? For now, no? Hindi pa siya observed. Okay. So, in these types of phenomenon. Okay. So, the energy of the photon is equivalent to 1.022 mega electron volt. So, ilagay nyo lang dito, 3 times 10 raised to 8. No? At dito, 9.3 or 9.11 times 10 raised to negative 31. So, try nyo lang. And then convert it to electron volts. Kasi, ang mass natin, kilogram, speed of light, squared, meters per second. So, magkakaroon ka ng, essentially, kilogram, meter squared per second squared, joules. Okay, then convert it, no? Huwag dito. So, 1 electron volt is equal to 1.602 times 10 raised to negative 19 joules. So, gamitin nyo lang yun for dimensional analysis para makuha ito. So, okay. So, in summary, no? So, meron tayong photon absorption din. Okay, ano yun? So, there are 3 ways in which EM photons interact, no, with matter. So, first, no, is the photoelectric effect, no, which is the energy, no, of a photon becomes the kinetic energy of the electron. No? We have Compton effect, no, in which the incident photon energy comes out as the kinetic energy of the electron plus the wavelength of the scattered light, or wave of the energy of the scattered particle, no, or wave. Okay. So next, no, for pair production, the energy, no, of a photon becomes the kinetic energy of the two particles plus their rest energies. Okay? So since pareho naman sila ng mass, twice, no, their rest energies, no? So kung babalik na rin mo siya, para siyang two colliding antiparticles yielding to a photon. Okay, so the threshold between Compton scattering and pair production is around 1.02 mega electron volts with crossover of 4 mega electron volts for heavier elements and 10 mega electron volts for lighter elements. Okay. So, ibig sabihin nun, so if heavier ang elements, no? So, ano mangyayari? No? Siyempre, mas magiging mataas din yung mass, kaya ang threshold for Compton scattering and pair production nila ay mas tataas din. No? So, for lighter elements naman, it could be the case that they can have a greater kinetic energy. So, okay. So, in terms of increasing energy, no? So, photoelectric effect, is less than the Compton effect's energy and very much less than the pair production energy. So, yan yung tatlong inaral natin. Okay. So, ngayon, from this, there are experiments, in which light is being seen, as light particles, no? And there are also experiments in which um, light is treated as a wave. So mainly in optics experiments, it possesses, the light possesses, ano yung four main characteristics niya, or four um, main properties niya. So light can reflect, light can refract, light can interfere, interference, and light can diffract, or diffraction, So that's why, no, in wave particle duality, we have a hint, of what optics really is, So here is an example of a Young's double slit experiment, no, okay, which you can see, ano nangyayari. So, ang nangyayari dito is, still, yung individual electrons or individual packets, are producing, or hitting the target, in a way that is similar to, ano, um, in a way that is similar to a normal, distribution. Okay? Yan. So, ngayon, di ba? Syempre, yung mas malapit, nasa mas mataas na area, Yung nasa mas malayo, mas konti lang, So, yung mas malapit sa butas, ay mas marami yung nahihit na target, or nahihit dito sa target. Yan ay pag particle, yung treatment natin. So, kapag naman wave, anong nangyayari? It produces, an interference pattern. So, nagkakaroon ng, anong tawag dito? Nagkakaroon ng amplification. Kung makikita ninyo, wala namang butas sa gitna, pero yung most probable area in which the wave, will hit the target is in the middle, And there are dark fringes, Unlike dito sa particle, So, para siyang dalawang normal distribution dahil sa dalawang butas dito. So, ngayon, we must combine, these two in order for us to get an idea, on what light is, So, now, we have that, a quantum object, a quantum object behaving, as if, it is initially, a wave, each quanta, passing through the slit, on both slits, because it is, quote unquote, behaving as a wave, and hitting the target individually as if it is a particle, So, kung isa-isa niyang ilalagay yon, it will give, an individual electron target pattern. But, by doing the experiment, more and more, it appears that the electrons or the wave packets, or the light quanta, or a quantum object, to have or to possess also an interference pattern. So, ano yung nag-i-interfere? So, nag-i-interfere siya with itself, And, if light, is both a wave and a particle, so, what is, what is waving, So, kung isa siyang wave packet, so, isa siyang quanta, tama lang naman, bilog-bilog, Pero pag wave, anong klaseng wave kaya yun, So, we will discover later, in the chapters, that we will study kung anong klaseng wave yun. Okay, anong klaseng wave ang isang quantum object. So, okay. So, ito na isa sa mga last slides natin. So, Okay. So the wave particle duality of nature, no, in the atomic scale. So depending on the experiment performed, no, matter sometimes show wave properties and sometimes particle properties, but not both at the same time. Kung makikita nyo kanina, di ba, as it is hitting the target, no, it is a wave, no, but once as it is passing through the slits, no, it is a wave, no. Pagdating sa target, it is now a particle. Sir, paano pag naglagay tayo ng detector sa gitna? No? So, halimbawa, maglagay ako ng coil of wire, since electron naman siya, na magde-detect. No? Halimbawa, kung nasan yung, kung saan dadaan yung electron. So, pwede, di ba? Kaso, ano mangyayari? By putting a detector, no, they have found out na nawawala, no, yung pagiging wave ng isang electron or ng isang quantum object. No? Okay. Magiging ganito lang din yung pattern niya if maglalagay ka ng detector. No? Kasi yung experiment mo ay now built into ano, the particle property, no, of the quantum. Okay? So, bakit kaya nagiging ganon? Kasi inherently, kung maglalagay ka ng detector, anong kailangan mo? Kailangan mo ng change in either current, no? Oh, syempre, change in current. So, paano mo madedetect yung current, no? By in itself, no? If yung electron ay dadaan sa loob ng halimbawa coil of wire, no? So, kung yung coil of wire na yon ay detect ng current, ibig sabihin, may something na malulose dun sa electron na yon, no? And from there, no? Your experiment is now, no, treating, no, the double slit as a deterministic, no, or tawag dito, you are now experimenting on the particle nature, no, of your object. So, ganun lang. Or halimbawa, so isipin nyo na lang ganito. Isa pa is if you want to try to detect, no, an electron, so syempre sobrang liit niya, 'di ba? Ano ang kailangan mong gawin? So you have to use your senses, no? So halimbawa, ang gusto nating gamitin na sense ay sense of sight, no? So kailangan, so para ma-observe natin kung nasaan yung electron or para ma-observe natin kung ano yung electron, we must pass, no? We must reflect, no, light into it. Okay, so pag nag-reflect tayo ng light doon, yung light na yun pupunta sa mata natin, madedetect natin kung nasan yung electron. Okay, pero pag nangyari yun, no, para mangyari yun, you have to have a source, no, of your photons. Kasi sa photons manggagaling yung light packets, di ba? Para makita mo yung electron. So, ibig sabihin, pag naglagay ka para mag-reflect sa'yo, no, yung photons, kailangan dumaan muna siya dun sa electron, no? And then, hindi mo na siya ma-observe, no? Kasi, yung photons ay magbibigay ng extra energy doon sa electron mo. Okay? Kaya, tawag dito, yung experiment mo ay hindi magiging successful to get its observation, no? So, kasi magbabago na yung kanyang energy, no? Okay. So, now, no, we can say that wag dito, light, no, can be observed as a particle and as a wave, no, depending on the type of experiment. So, in terms of reflection, no, so it can be observed as wave, no. There are experiments, no, with reflection, no, that treats light as a particle and also a wave, no. So ganun din sa refraction. Sa photo emission, no, pwede lang siya kapag ang light mo is treated as a particle, no? Pero yung polarization, diffraction, and interference, no, nangyayari lang siya kapag you treat light as waves, no? Okay. So, yun, depending on the experiment. And, now we turn on its, we turn on to our conclusion na, light has a dual nature, no? Sometimes, it can behave like a particle, and sometimes, no, it can behave, no, like a wave. Okay. So, here, we can see, no, the first ever photograph, no, of light as both a particle and a wave, no? So this work represents a collaboration between the Laboratory of Ultrafast Microscopy and Electron Scattering, no, or EFPL, no, the Department of Physics in Trinity College and the Physical and Life Sciences, no, Directorate, no, of the Lawrence Livermore National Laboratory. The imaging was carried out, no, EPFL's ultrafast, energy filtered transmission electron microscope, one of the two in the world. So kung gusto niyo makita, no? Ayan, ito yung first ever picture niya. So ito yung picture niya as a wave, no? Picture niya as, no, a particle, no? Okay. So kung makita niyo, no, para lang siyang may zones, no? So para lang siyang equipotential surfaces pagdating sa kanyang particle nature. Okay. Any questions so far? May tanong po ba? Wala naman. Okay, sige. So, tuloy tayo. Okay. Mhm. So, saan ba ginagamit yung mga to? So, bakit natin kailangan pag-aralan? So, meron tayong tinatawag din na scanning and tunneling, no? Electron microscope. Okay, sabi natin, no? Yung light, no? So, yung light microscopes, limited lang tayo sa wavelengths, no, ng light bago siya maging aberrations, no? So, hindi natin kayang i-image yung very small very small organisms like virus, no? Pero with the help, no, of electron microscope, no? So, ito pa isa niyang use, no? Ito ay false color image lang, no? Hindi siya totoong image, no? So, it is a graphical image of T4 bacteriophage, no? Via electron microscope. So, dahil sobrang liit, no, ng tawag dito, ng wavelengths, no, ng electron microscope, pwede siyang gamitin for imaging very small objects, no? So, kasi hindi agad siya nag-produce ng aberrations, no? Aberrations, kung napag-aralan ninyo, yun yung kapag halimbawa, tawag dito, yung resolving power or yung lens na gamit ninyo ay hindi na makapag-produce, no, ng sharper image, no, than what you can see, no? So ganun din minsan sa lens ng light microscope. Okay? So okay, kaya electron microscopes na yung ginagamit natin. So ngayon, after this, no, maikling pahapyaw lang sa atomic nature of matter. So bakit? Bakit kailangan natin ng atomic nature of matter? So we can use this as an introduction kasi yung next natin na topic ay all about Schrödinger's equation na, no? So kailangan natin tong overview, no? Pero hindi naman natin i-discuss lahat. Hindi natin i-discuss tong last three, no? Kasi ito ay after pa niya. Okay? So medyo caught up in the middle lang tayo. Kaya hindi na natin gagawin muna lahat ito, no? And kahit dun sa arrangement, no, ng reference book natin, no, after ng wave and particle nature of light natin, no, we will move on to Schrödinger's equation before the atomic theory, no? So atomic theory being the Rutherford, no, Bohr model, no, chapter 6 and 7, no? So Essentially, gawin natin to na parang 4.5, no? So yung 3 and 4 kanina, ito yung 4 and 5. Okay. So, since education students kayo, so may I ask kung do you have an idea kung ano yung ibig sabihin ng atom? So, so si Cedric. Hello, Cedric. Meron ka bang any idea? Unmute, please unmute yourself. No? So, Cedric, nandyan ka ba? Ayan. Sige. Since we're on the atomic nature of matter, so, do you have an idea or halimbawa, nung bata ka ba, tawag dito, tinanong mo na ba yung sarili mo kung bakit yung papel na ginupit mo, pag ginupit mo ng ginupit, magiging pinakamaliit na papel ba siya sa buong mundo? Ganon?
Hindi po, pero natanong ko na po dati yung or naisip ko na po dati yung parang hanggang ano yung limit nung sa pagtutupi ng papel.
Mm-hmm.
So bakit hindi na siya pwede pang itupi after that?
Oo.
Diba sabi ata nila sa 20 po ata yung maximum, din hindi na pwede kahit na anong gawin mo, kahit gano'n pa kalaki yung papel.
Tama. So, pag sa regular na paper yata, yung mga A3, A4, ang maximum yata ay 7. Tama ba? 7. Oo, pero pag gumawa ka ng custom na paper, you can make it, you can fold it multiple times, more than 7. At nangyayari yun dahil saan? Sa interactions between between yung sa on the spaces yung sa pagtupi mo so kung makikita niyo kumakapal yung gilid, di ba? So yan, so tama so may mga bagay na may limit so halimbawa yung pagtupi ng papel or ano pa ba yung mga bagay na may limit so kung ilang oras lang kayo pwede mag-computer sa isang araw. Or in our younger days, gano'n lang tayo katagal pwede maglaro. Di ba? Okay. Ngayon, noong araw, noong unang panahon, siyempre, yung mga limit ng mga bagay, so dahil nga, puro lang sila discourse, so hindi pa naman gano'n ka-develop ang ating science and technology, so, so people have long asked, okay, so dahil they're just existing okay, di ba? So if they're existing, what is the world made of, So yan, natanong niyo na ba sa mga sarili niyo yan? So and what holds it together? So why is the earth like this, di ba? So bakit may mga puno, bakit may halaman, bakit may may lupa, may tubig, Bakit pag kumidlat, tapos tinamaan yung puno, nagkakaroon ng apoy, So bakit may hangin, bakit bumabagyo? Siyempre yun. So, okay. Ngayon, thinking, fundamentally, So it could be that ang tao kasi mahilig mag-organize, Mahilig mahilig bumuo ng classifications, Kaya alam niyo, meron tayong tinatawag na halimbawa states of matter, ganitong organization, ganitong party list, ba? Okay. Kasi people, or the collection, of an individual, person is ano tawag diyan? Self-organizing structure, So halimbawa nga sa sa klase ninyo, So maaring merong ganitong magkakabarkada, tapos si ganito kabarkada niya rin si ganyan, So meron siyang 5 iba pang kabarkada sa klase ninyo. So tapos nakabibilang pa siya sa 3 iba pang grupo. So people like to group their selves, And people like to group, other things, So ngayon by being very curious, dahil since wala pang scientists noon, ano pa lang? Well, it's arguable what the meaning of scientist should be at that time. no? So pero we can say that basically, no, uh, these things, no, are questions of philosophers, no. So people, no, have come to realize, no, that the matter of the world is made up of a few fundamental building blocks. So halimbawa, pwedeng nasa iisang uri lang ang lahat ng tubig, no, sa mundo. Lahat ng halaman at puno, iisa lang din. Lahat ng lupa, no, iisa lang din, no, ang kanyang building blocks, no. Okay. So by fundamental building blocks, we mean the objects that are simple, no, and structureless, no, not made of anything smaller. So halimbawa, ang analogy kasi niyan is ang individual, no, meron siyang mubuo siya ng family and mubuo siya ng so community, and then mubuo siya ng government, no. So yung simple, no, and structureless ay yung individual, no, person, no, not made of anything smaller, no. So ano kaya yung katumbas nun, no, in the physical world, no? Okay, so we have, no, early Greek theories, no. So ito is sa mga pinakamagandang pag-aralan, no? May philosophy kayo nung senior high kayo, no, tsaka na tong college, tama pa ba? Hello?
Yes, senior high po.
Senior high. Ngayon, wala kayong philosophy ngayon?
Wala po yata.
Okay. Okay. Well, baka kasama na sa sa other theories of education ninyo yun. Okay. So, so punta tayo sa Greek theories, no? So, syempre, pinaka-famous dyan. So, 400 BCE, no? So, Democritus, no? Thought of matter could not be divided indefinitely. Ibig sabihin, ano yun? No? Once na yung bato ay sinira mo, no? Mayroong bits na malalaki, may bits na maliliit, and then after that, no, hindi mo siya pwedeng paliitin infinitely, no? Ibig sabihin mayroong pinakamaliit na unit ng bato. Okay? So this led to the idea of atoms. So ang atom, no, ang kanyang root word ay atomos, tama ba? So meaning indivisible, no? So for which cannot be divided, no? So yun. Okay. So 50 years later, no? So Aristotle, no, one of the greatest philosophers, no, in this era, no? So it modified an earlier theory that matter was made up of 4 elements. So made up pa lang ha, wala pang alchemy nito. Wala pang combining them to get gold. Okay? So yung 4 elements natin ay fire, no, air, water, earth, no? Parang basis ng mga tawag dito, basis ng mga anime at iba't iba pang storya, no? Kung nanood kayo ng Encantadia, ganyan din. Avatar, no? Okay. Pero, there is a deeper meaning, no? Kung bakit niya ginawang 4 elements, no? So, halimbawa daw, yung bato, no? It is made up of earth. Bakit daw? Kasi, yung bato raw, no, nalalaglag, no? So ganun niya rin in-explain yung gravity, no? So yun. Kaya nalalaglag yung mga bagay, no? Kasi they are attracted, no, to what their initial form is, no? So ganun daw. Okay? Kaya daw yung hindi daw kaya rin umuulan, no? Pupunta rin sa tubig. So kasi pareho silang nasa baba. So meron pa akong nabasa na yung apoy daw, no? Kaya siya pataas, no? Yung motion niya pataas, no? Kasi in part daw yung apoy, no? At hangin, no? So pwede silang pwede silang i-divide, no? Merong silang ganitong division, no? So yun. So fire contains, no, air daw, no? Partly, no? Kaya siya paangat. So ganun. So next, Okay, it was believed, no, that all matter was made up of particles called atoms. And by definition, atoms were the smallest bits, no, of matter that could exist, no. So, ayan. That which can, ayan, sinabi na natin, no? Alpha, tau, no? So, mu, tsaka, ano to? Nu, no? Okay. So, atomos. So, today, we know that there is something more fundamental than earth, water, air, and fire, no? So, okay. Next. So, mga kasunod doon, so Democritus and Leucippus, no, they speculated that unchanging substratum of the world was atoms, no, in motion. So, yun daw ang bumubuo sa mundo. So, ito maririnig niyo sa chemistry si Antoine Lavoisier or Lavoisier, no, Lavoisier, no, established, no, the conservation of matter, no. Ito yung pinaka-fundamental sa chemistry. Kung sa physics, no, energy raw, ang sa chemistry daw ay matter. Matter cannot be created nor destroyed but can change in its form. Okay? So next, no, si Dalton, no, he perceived, no, the atomicity of nature in the law of multiple proportions, no, of the compounds. Okay? So meron lang certain, no, proportions for which compounds can be ano, can be produced, no? So halimbawa H2O, no, meron lang siyang CO2, okay, H2, okay. So meron lang silang proportions, no? So ibig sabihin um, there are things, no, na hindi mo pwedeng magawa 'yon. Okay. So si Avogadro naman, so postulated that all pure gases at the same pressure and temperature have the same number of molecules per unit volume. And kung ilan 'yon ay determined by the Avogadro's number, 'di ba? 6.02 times 10 raised to 23. Tama ba? 23. No? So, ang unit ng Avogadro's number ay atoms. No? So, 6.02 times 10 raised to 23 atoms. No? And finally, no? So, si Maxwell, no, showed with his kinetic molecular theory of gases, no, how macroscopic quantities could be derived, no, from the averages over distribution of molecular properties. Ito ay yung tinatawag na Maxwell distribution. Okay. So, statistically. Okay. Okay. So, the experiments which showed the composition of atom, no, are ayan, Faraday's law of electrolysis, Millikan oil drop, no, Thomson's measurement of the charge to mass ratio, and the Rutherford scattering experiment. So, okay. So, so halimbawa, meron tayong electron, no? So, it can have a mass, no? It has a charge, no? It has a spin, no? And it has particle and wave properties, no? Okay, so so inside one electron, no, has all these properties, no? In all these information are stored, no, somewhat, no? So, is the atom fundamental? So, okay. Some primary discoveries show that the atom, no, is composed of light, negatively charged particles orbiting a heavy, positively charged nucleus, no? Pero it was found out later that the atom is not the fundamental building blocks, no? Well, it is the fundamental building blocks of everything, but atom is not a fundamental particle because it is still made up of other subatomic, no, particles. Okay? So, ngayon, we can argue that the atom is fundamental in terms of its function, no? So, pwede kang magkaroon ng electron, pwede kang magkaroon ng proton lang or ng neutron lang, pero with those subatomic particles, a whole cannot function, no? So, parang sa biology, 'di ba? yung cell ang fundamental. Pero yung cell ay built pa rin by different ano organelles. Organelles ba yung tawag doon kapag sa biology? Oo. I think so, no? Itama nyo na lang ako kung mali yung pagkakaalala ko, no? Organelle yata yung tawag, no? Yung mga parts of the cell. Okay. So, ngayon, so we have Faraday's law of electrolysis, no? To get the mass, no? So, the mass equal to the charge, no? Times the molar mass, no? An object, no? Or of the atom divided by the valence times kung gaano kalaki yung charge nito. So, an example. So, wag na nating patagalin to. No? So, how many grams of barium and chlorine will you get if you pass a current through a molten BaCl2 for 1 hour? Barium has a molar mass of, okay, wag na yan. No? So, in electrolysis, no, we can get, the mass of the elements. No? So, ito naman, so Thomson's charge to mass ratio of electron, no? May electric source and then may cathode and there is a magnet, no, that can anong tawag dito? Deflect, no? Okay. It's anong tawag dito? It can deflect, no, yung position, no, ng incoming electron. So, from this, no, it is subject to magnetic field and electric field para para pagdating dito, alam niya yung angle, no, of deflection, no? So, ayan. So, nakuha niya yung charge to mass ratio to be 1.76 times 10 raised to 11 coulombs, no, per kilogram. Okay? So ngayon, kailangan na lang nating malaman kung ano yung fundamental charge or fundamental mass to get the other one, no? So ngayon, okay. So from Thomson's charge to mass ratio ng 1897, so kung makikita niyo rito, 1833 yung electrolysis, no? To get the mass, no, of the elements. So to get the ratio of charge to mass, dahil sobrang liit nito, no, 1897 na siya nagawa. And after that, no, so Millikan's oil drop experiment noong 1909. Okay. So it is an experiment conducted wherein oil droplets are sprayed, no, into tawag dito? The two plates, no, having different charges, no, at merong butas yung upper plate para konti lang, no, yung atoms, no, or yung oil droplets, no, na mapupunta. So yun, atomizer, eyepiece para makita niya, no, nakuha niya yung area, no. So yan, charge or droplet under observation, electrically charged plates, no. And then may pinhole dito para isang oil droplet lang yung nakita. Ngayon, dito pwede niya i-vary yung charge, no, so that the force of the gravity, no, will equal, no, the electric force, no. So para zero, para floating lang siya. So by using this, nakita na yung charge of electron is 1.6, no, times 10 raised to negative 19 coulombs. So from there, no, makuha niya na yung mass by equating the fundamental charge divided by the charge to mass ratio of electron. Okay? So ito naman, okay, yung alpha scattering experiment. Okay? So chinek ni Rutherford if atoms have spaces, no, between them or if they do not, no. So okay, kung paano yung structure, no, ng atom. So meron siyang gold foil at tawag dito, helium-4. Pagkakaalala ko dito sa source of particles niya. So dito meron siyang ang dalawang, no, results. No? If atoms were permeable, no, and neutral, no, the alpha particles would simply pass through the gold foil and strike the back of the screen, no. So dito lang siya, no. But what happened was, no, some were deflected at large angles, no, or even scattered back, no. So ngayon, dahil doon, we have to edit, no. So um our description of what an atom is and what it is made of. Okay. So since some of the positive alpha particles were substantially deflected, Rutherford concluded that there must be something inside of an atom of the alpha for the alpha particles to bounce off that is small, dense, and positively charged. No? Ibig sabihin, no? meron tayong nucleus. No? Okay. So, yan. So, ito yung thin gold foil niya. Yung kanyang detector. No? Yung kanyang screen. No? Na detector din. Okay. 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 So, ito yan. So, nagkakaroon ng extra deflected particles. So, ibig sabihin, no? Yung atoms natin, no? Ay made up of tawag dito, a part, no, that is not moving, and there is a part, no, that is making it, no, distant, no, to other particles, no. So hindi sila absolutely na magkakadikit, no. So yun lang. So next, no. So dito na tayo pupunta sa models, no, of atoms. So puntahan lang natin yung Daltons, Rutherfords, no, Thomson, Rutherford, Bohr, and the De Broglie, no, model. Bakit? Kasi yung De Broglie model, pinaka-importante dahil this exhibits, no, the wave-like properties of the particle. So yung other slides dito i-skip na natin, no, dahil yun yung mga pag-aaralan natin sa atomic, no, theory, no, yung mga tawag dito, spectroscopy lines, no. Okay. So okay, so meron na tayong proton, no? Yun yung hindi magagalaw from the Rutherford's tin foil experiment, no? Tin gold foil experiment. So, okay. So ngayon, so very long ago, no? Naisip na rin to at na-observe na rin, no? That materials, no, when rubbed, no, they can develop a charge difference, no? So, this electricity is called okay, cathode rays, no? When passed through an evacuated tube, no? These rays have a small mass and are negative, no? Okay. So Thomson noted that these negative subatomic particles, no, were a fundamental part of all atoms, no? So okay. Okay. So initially kasi ito yung first sentence natin, no? Yung rubbing na yon ay product of triboelectric, 'di ba? Effect. Okay. So yun daw excess, no? Particles doon, no, that makes it attracted or repulsed, no, ay depende dun sa particles na yun. Okay. So so when passed through an evacuated tube, no, yung particles na yon ay pwedeng tawagin na cathode rays, no, yung electricity, no, that makes, no, charge difference possible. Okay. So Thomson noted, no, that these negative subatomic particles are fundamental for all atoms, no. Okay. So in 1803, no, meron tayong Dalton's model. So, isang bilog lang siya. Okay? So, atoms are solid and indivisible, di ba? For that which cannot be divided, atomos, no? Indivisible. Okay. So, pero sabi ni Thomson, no? There are negatives of atomic particles, no? In the atoms. So, ibig sabihin, naglagay siya ng, ayan. So, yung tinatawag na natin ngayon na electron, no? So, ibig sabihin, each particle has an electric property, no? So, yun na nga yung tinatawag natin na electron affinity, no? So, ito yon, no? Dahil sa Thomson's plum pudding model. So, para lang siyang pudding na may palaman na electrons, no? Okay, negative electrons in a positive, no, framework. Dito, yung positive part ay yung buong atom, no? So, ngayon, dahil naman kay Rutherford, nagkaroon na ng part na positive at nagkaroon na ng part na negative, no? So, dahil years later, dahil alam na nating may electron at merong something na stationary, no? Kaya nade-deflect yung atoms, no? Dahil sa very heavy positive charge, no? Doon sa tinatawag ng nucleus. Kaya nagkaroon ng planetary model, no? Pero he said that atoms are mostly empty space, no? Ibig sabihin, sobrang layo, no? Ng pagitan, no? Ng proton sa electron, no? So 99 point ilang 9 ba 'yon? 4, 5, 9% empty space daw ang isang atom. Pero bakit natin nakikita ang isa't isa, no? Naririnig at nakaka-interact if, no? Atoms are mostly empty space, no? So medyo confusing, no? So okay. He also said that negative electrons orbit, no? The positive nucleus. Pero yung orbit na to ay hindi totoo or hindi naman sa hindi totoo. So yung orbit ay hindi talaga orbiting in such a way na similar sa pag-orbit ng planets, no? So yun. Kasi so saan lang yung orbits na yun? So dahil wala namang orbits, hindi naman siya traveling in a two-dimensional manner. Hindi rin naman siya orbiting in a three-dimensional manner dahil hindi naman fixed yung kanyang tawag dito distance, no? Meron lang tinatawag na most probable distance or average distance. Ngayon, yung model of atom na pinaka accurate ay yung model of atom na merong cloud of probability, no? So kaya meron tayong yung mga S, P, D, and F shells, no? So yung shells na yon, no, or yung ano bang tawag, anong tawag dun sa chemistry? Molecular geometries, no? Yung molecular geometries natin, no, gives us the most probable position of the electrons in an atom or a compound, no? So yan lang. So electronic configuration is the mnemonics that we have, no? When describing, no? Tawag dito when describing the shape, no? Yung electronic configuration, no? Ang dinidescribe niya talaga ay yung shape, no? Ng ng atom, no? And ng compound, no? If there is, no? Okay. So, yung mnemonics na yon, no? So, kasi doon makikita kung nasa ang shell, no? Yung electrons ng isang atom, no? Yun nga, meron lang most probable positions, no? Kaya nga siya shells, no? Yung tawag sa kanya, no? Hindi siya orbits. Okay. So, ngayon, going back, no? So, Dalton's model is based from the ancient Greek, no, philosopher Democritus, no, to the time of John Dalton, no. So, ganyan lang siya, no. basic atom lang siya. No? Atom is the ultimate indivisible constituent of matter that which cannot be divided. No? So kahit anong talim pa ng kutsilyo mo, no? Yan. So hindi mo siya hindi mo siya ma-divide. Pero, 'di ba? Dahil sa Hadron Collider, 'di ba? So alam natin na meron pang subatomic particles, no? Nagkaroon tayo ng powerful enough tool para pakita, no? Or ma-divide, further yung atom, no? So, napakagaling. Okay. So, Thomson's model, no? Or the plum pudding model. So, ito, ayan. So, medyo weird yung kanyang shape, no? So, isang malaking positive lang daw. Tapos, mayroong maliliit na negative charges, no? Dun sa atom. So, 4, 7, 8, 9, 10. So, ano yung 10? So, neon atom to. Tama ba? Okay, so we have a sphere of positive charge and an electron. Pero way back then, hindi pa siya thought of as weird kasi napag-aralan natin sa electricity and magnetism na there can be a sphere of positive charge. Tama ba? Meron tayong tinatawag na conducting shell and conducting ano yun? Solid sphere, no? Conducting solid sphere. Okay? Or insulating solid sphere, meron din. 'Di ba? So, since the atom is electrically neutral, no? So, Thomson proposed that the atom is a solid ball of positive material and the negative electrons are distributed throughout the heavier positively charged jelly, much like raisins embedded in a positively charged pudding. So, okay. So, yun. So, to equate, no? yung positive from the negative. Okay. So, atoms are not the smallest particle. So, dito na nagsimula, no? So, atoms are not the smallest particle of matter, but to function it, no? For it to function, no, it needs, no, its subatomic, no, constituents. Okay. So, ito na. Next is yung Rutherford's model, no? So, from his experiment, no? So, atom has a tiny dense positively charged, no, core. So, yun yung nagkakos ng deflection, no, called the nucleus, in which nearly all the mass is concentrated, around which the light negative constituents, no, called the electrons, revolve around in orbits, no, at some distance, which much like planets revolving around the sun. Okay? So, ito na yung deficiency ng Rutherford's model. So, Rutherford's model cannot be reconciled with the theories of electrodynamics at that time. Bakit? Kasi, kung may positive charge, no, na nucleus at may negatively charged orbiting, ang mangyayari dyan, dapat maa-attract yung negative charge, no, sa positive charge, no? So dapat nagko-collide sila, no? And that cannot happen, no? Based on our understanding of electrodynamics, no? Okay. Ayan. Why are the electrons not attracted to the electrostatic forces closer and closer to the nucleus, no? So okay. So yung sagot, no? Because the electrons revolve around the nucleus at such high speed, no, that centrifugal force balances the electrostatic force. So tingnan niyo yung mental acrobats na ginawa para lang, no, ma-resolve, no, yung deficiency na yun. So but according to the laws of electrodynamics, no, these accelerated electrons would have continuously radiate energy, no, in the form of EM wave. So ibig sabihin everything must be radiating, no? And possibly because of the high speeds, no, mataas din yung frequency, no, na ini-emit, no? So parang ang hirap, no? So if so, the electrons would lose energy and would therefore slow down and be attracted to the nucleus. So this would result in the collapse, no, so of the atom. So yun yung isa sa mga deficiency. So ngayon, okay. So ito, maiba muna tayo ng usapan. So dispersion of light, no, through the prism. So okay, makikita ninyo, no? So ay, okay lang pala yan. Okay, so when an incident, no, light, no, passes through a prism, no, it is broken down into its constituent, no, colors, no, the colors that make this up. Okay. So, meron tayong tinatawag na Fraunhofer spectrum. Okay. Okay. Dito sa spectrum na to, sinasabi na every atom has a signature. No? Signature spectrum. So, kagaya ng XRD na tinalakay natin kanina. No? So, ito. So, ito yung solar spectrum. So, visible portion showing prominent Fraunhofer line. So, ayan. Okay. Next. Okay. So, now, from dispersion and the spectrum that we have, we have this. So, why do different chemicals produce different colors? So, green fireworks, for example, came from barium. The yellow ones from sodium, are from red from strontium, blue from copper, and ito, yung purple one is from titanium being burned, So other colors can be okay. And pag nagsunog ka rin ng iba't ibang materials, ayan, yan din yung colors niya. Okay. 4, 5, 6, 7. Okay. So ngayon, from dito, na-invento yung spectroscopy, So, okay. So when a narrow beam of light, or what hot white light is viewed through an instrument that acts as a prism, the light is separated into its component parts, creating a continuous spectrum. So, halimbawa may gas ka, at ito lang yung lines na nagre-register, So, gases emit light of different wavelengths depending on the elements, present. When viewed through the instrument, a gas appears as a set of bright lines. So, ito, yung emission lines niya ay from the hydrogen. Okay. So, yan, emission lines. So, next. Okay. So, when white light travels through a gas before separating, as in the sun, so the gas absorbs some of the light, leaving dark lines indicative of the elements, present. So, meron naman ditong absorption lines, So, dito, ano nangyari, The gases that emit light, Yung example natin dito. Dito naman, yung gas nag-act, as the absorber of those light, Okay. Next. So, ito na. So, emission spectrum. Ito, lampasan muna natin to kasi ito yung topic natin after the quantum mechanics part, After yung Schrödinger equation. So, ayan. So, emission spectrum, hydrogen. Ayan. So, yun muna pansinin yan. Okay? So, ayan. Ito na yung resolution, So, na-form, yung emission spectra, dahil dun sa deficiencies, ng previous arguments natin, sa positive and negative charges being inside the atoms, Okay, so ito yung Bohr's postulate. So sa mechanical stability, electrons move about the nucleus in circular orbits, So sabi niya, yung Coulomb force, equates, the centripetal, force. Okay. So for the quantum condition, it is only possible for an electron to move, in an orbit for which its angular momentum is an integer multiple, So yon. Ibig sabihin, tawag dito. So to achieve mechanical stability, kailangan equal tong parts na to. So in quantum, kailangan yung angular momentum mo ay a certain value lang. Okay. Kasi kung hindi, ganito yung mangyayari, di ba? Mag-spiral inside lang siya. So, the constant total energy. An electron accelerating, in allowed orbits, does not radiate photons, So, yun yung postulates niya, Okay. So, mangyayari lang if it absorbs, or if it gives off, an EM wave, ang mangyayari lang ay it will jump, into those discrete shells, or discrete orbits, So, ganun lang yung mangyayari. Ayan. Okay. So electrons can jump from one orbit to another by emitting, no, or absorbing energy, no. So electrons travel in defined circular orbits around the radius. Okay. So unless, no, it jumps, no. Okay, emission and absorption are not possible. So one electron jumping from an orbit, no, from the outer shell or the outer orbit towards the inner, no, emits, no, a photon of red light, no, with an energy equal to 1.89 electron volts. So there are certain definite electron orbits which are stable or allowed, no. When electrons are in these orbits, they are exempt, no, from the rule that electrons revolving in orbits continuously radiate energy. So ibig sabihin, no, he postulated this in the need because of the need, no, to um, to align, no, the experimental results, no, from the theory to the theory, no. So yeah, kaya siya nagkaroon ng kanyang theory. Okay, so okay, saka na to, saka na yan. Ayan, so meron tayong tinatawag na Bohr radius. Okay, saka na yan, saka na yan. So ayan, so ngayon, yan. So ngayon, ang model naman ng hydrogen atom ni Bohr ay, ayan, so the radius of the hydrogen atom when its electron is excited, no, is proportional to the Bohr radius by a factor of n squared, no? So andito siya. Okay. So ngayon, dito na nabuo yung concepts ng ground state and excited states, no? So kapag nasa neutral lang siya, no? Wala siyang nasa minimum energy siya, ngayon yung ground state, no? So yung first excited state ay ito, no? So it can give off, no, its energy to move back, no, to the ground state, no? Okay. So yan lang. Okay. So okay, why is it successful? Ayan, because it explains atoms emission, no, of line spectra. It predicts the wavelength of the emitted light, no? So it explains also the absorption spectra. It ensures, no, the stability of atoms and accurately predicts ionization energy for hydrogen. Kung makikita nyo, hydrogen pa lang, no? So, and as far as I can remember, no, ayaw niya pa agad i-release yung kanyang study, no, yung kanyang postulates dahil hindi niya pa ma-work out yung sa other elements, no, sa hydrogen pa lang. And then he corresponded with a colleague, no, and that colleague replied to him saying, parang ang gawin niya is parang induction, no. So kung if this is possible to hydrogen, no, sabihin mo na lang din na in the future, no, it is possible, no, also for atoms with heavier masses, no. So yun lang. Okay. So spectral lines, hindi na muna. So wala na muna to, yung Lyman, Balmer. So okay, ito maganda to. So last 3 slides na yata to. So ngayon, meron tayong tinatawag na correspondence principle, no? So yung combination ng classical electrodynamics at yung Bohr's atomic model, no, determine the properties of radiation. So we need a principle to relate, no, the new modern results with the classical ones. So the Bohr's correspondence principle states that in the limits, no, where classical and quantum theories should agree, the quantum theory must reduce the classical result. So ibig sabihin, no, in the correspondence principle, ang fundamental ay yung quantum. Okay? Hindi yung classical. Hindi ito tayo classical to quantum, no? Because classical, the classical theory cannot explain, no, the quantum theory. But, no, quantum theory, no, so by inserting, no, halimbawa for a very large mass, for a very high, for very slow speeds, Okay. So, quantum theory, no? Results, no? To the classical result, no? So, yun. Kaya meron tayong tinatawag na classical and classical limit. So, excuse me. In the future, no? No, in our next meeting, no, once we are done explaining the quantum theory, no, via Schrodinger equations, no, we will discuss, no, how this happens, no. So, as an introduction, meron tayong De Broglie's hypothesis, no. So, sabi kasi natin previously, no, waves, no, or things that have wave properties can have, no, particle properties, no, kagaya ng light. Ngayon naman, kay De Broglie, binaliktad niya, no, that a moving particle, no, such as a photon or electron, can be associated with a wave, no, and the wave associated is the De Broglie wave, no, or a matter wave. So, ito na. So, okay. So, we have, no, yung derivation of De Broglie wavelength, no. So, yan. So, Planck's quantization of radiation, so proportional to Planck's constant and the frequency, light, no. So, for Einstein's equation of energy of a photon, so para completely wave siya, no, or completely kinetic siya dahil wala namang rest energy ang photon. So, ayun, by equating these two, no, P is equal to H over lambda, or lambda is equal to the Planck's constant over the momentum. No? Okay. So, ibig sabihin, particles, no, can have wave properties, no, and that wave property is the De Broglie wavelength, no. So, ayan. So, the De Broglie wavelength is explained, no, here, similar to a vibrating string, no. Only multiple or wavelengths are allowed, no. So, in an electron, no, only whole numbers are allowed. So, ayan, 3 wavelengths, 5 wavelengths. Okay. So, yan ang visual representation ng De Broglie wavelength, no? Okay. So now, we have our last example, no? So, compare, no, the De Broglie wavelength of 46 gram golf ball with velocity 30 meters per second and an electron with velocity 10 to the 7 meters per second. So, kung makita ninyo, A, no, the velocity is very much less than the speed of light, no, and the mass is very large, no. So, yung De Broglie wavelength of a golf ball is 4.8 times 10 raised to negative 34 meters, no. Sobrang liit ng kanyang wavelength that it is in the region of the Planck length limit, no, times 10 raised to negative 34. While for an electron, no, so yung kanyang velocity still very much less than the speed of light, pero 10 to the 7, no. So hindi man siya lang siya, ilang percent lang, 10%, kasi 10 to the 8, di ba? So, di ba, mga 3% lang siya the speed of light. So, very small pa rin. So, pero kung titingnan, no, the De Broglie wavelength, no, of the electron is very much larger than that of the golf ball. Ibig sabihin, yung very small objects, no, yung quantum objects, no, have larger De Broglie wavelengths, no. So, yung golf ball, kaya hindi siya nagbe-behave as a quantum particle dahil sobrang liit ng kanyang De Broglie wavelength that it becomes impossible to observe, no, its quantum behavior. So, yun. So, okay, applied to the atom. So, De Broglie's hypothesis states that, no, one of Bohr's assumptions concerning his hydrogen atom was that the angular momentum of the electron nuclear system in stationary state is an integer multiple of h over 2 pi. So itong h over 2 pi, makikita nyo to in the future as h bar. Yung h na mayroong ganun sa taas. No? May hati sa taas. No? H bar. So the electron is a standing wave, no, in an orbit around the proton. This standing wave will have nodes, no, and be an integer number of wavelengths, no. Yung integer number is yung kagaya nung nasa visualization kanina, no. So walang putol dapat. Ito. So hindi pwedeng ganito. Dapat either ganito siya or ganito. So yun lang. Okay. Ayan. So, ayan, 2 pi r. So, ito, equals sa n lambda. Multiple, integer multiple of the wavelengths. No? Yung 2 pi r is the circumference. So, the angular momentum becomes, ayan. So, the angular momentum becomes the h bar times n. No? So, where n is the quantum number that we know and love. So, okay, finally. Okay. So, electron scattering. So, Davidson and Germer experimentally observed, no, that electrons were diffracted. No, very much like X-rays. Ibig sabihin, ano, if they are diffracted, no, and diffraction is a light property, no, electrons are behaving as waves too. Okay? So, 5 years after the Broglie hypothesis, no, he obtained his Nobel Prize. No? So because of the proof, no, based on experiment, no, given by Davidson and Germer. Okay. So finally, no, yung limitations of Bohr model natin. So it works only on single electron atoms, so hydrogen mainly, no. It could not account for the intensities, no, of the fine structure of the spectral lines and could not explain the binding atoms into molecules. But with its limitation, no, konting dagdag na lang yung kailangan, no. So kailangan natin explain itong deficiencies na to, no, to come up with a better theory that is suited for the complete atomic model. Kaya yun yung i-discuss natin later. No? So, ito na yung last slide. No? So, in the beginning, no, of our topic, no, ano yung tinanong natin sa inyo? So, ano yung tinanong natin? So, how would a physicist, no, or how would a physics student, no, write the Bible? Tama? So, sabi natin, kanina last week, no, paano natin describe, no, na in the beginning, no, God created the heavens and the earth, diba? And He said, let there be light. So, dahil lang meron lang tayong, ano, number one, meron lang tayong universal gravitation, and meron lang tayong electricity and magnetism. So, ngayon, with all the knowledge that we have, no, so, our last, no, slide would be regarding the the story of creation based, no, on physics, no. So how would the physicist write a biblical story of the creation nowadays? So because of the multiple theories that we have, diba? We can see that in the beginning, no? So everything started, no, with one proton, no, which is the hydrogen. No? And God said, let there be light, no, from Maxwell's equations. No? And God created time and space. Right? So, and further by creating humans, no, and with the help of uncertainties principle, no, we're able to achieve, no, free will, because nothing is deterministic in this world, in the atomic level, no. Okay. So, yun lang, no. Okay. So, thank you for listening, no? So, okay. So, we'll end this with a quote from Niels Bohr. Everything we call real is made up of things that cannot be regarded as real, no? So, such as quantum mechanics. So, if quantum mechanics hasn't profoundly shocked you, so ibig sabihin, we haven't understood it yet, no? So, from time to time, no? We think that we understand, no? Quantum mechanics, but in reality, it still becomes more elusive, no? Every time we read it. So, okay. So, ito na yung last slide, no? And, no? Okay. So, from this, no? Ituloy niyo lang yung assignment ninyo. So, ba, nagbigay ako ng assignment last week. So, kung may hindi pa nakatapos ng assignment, so, ituloy niyo lang. And, with that, no, kasama na yung assignment 3, no? So, yung assignment 3 natin is ito. So, yung 1 and 2, siya na yung 3, yung 2 and 3 respectively. So, yung 2 kung hindi nyo pa napanood, so panoorin nyo. So, this is a 2-part special. So, kung medyo naboboard kayo sa bahay, wala kayo bang magawa, pwede nyo nang panoorin yung part 2. Pero yung part 2 is mainly reserved ko lang for biology students, no? So, pero maganda na makita nyo rin, no? Kung ano yung biology applications ng mga pinakita dito, the first part. So, okay. And then next, so create a piece of art, no? Related to our topic, no? So, which is the wave particle duality and intro to quantum. So, are there any questions? Mga kapatid, no? So, mga 28 na kapatid, may mga questions ba kayo? Sarah, President?
Wala naman po.
Wala na. So, yun lang, no? Diniscuss lang natin para matapos tayo. Next week, we'll move on to chapter 5. Okay, ano yung chapter 5 natin? Okay. So, ayan, basahin na, no? Yung Schrodinger equation. Okay, so, sabihin niyo lang kung Wednesday ulit tayo next week or mag-iiba tayo ng araw para informed lang lahat, no? So, thank you so much, no? Okay, 9:23 pa lang. So, pwede pa kayong Anong oras ang exam ninyo, Sarah?
12 po.
12. O sige, ayan, mag-review na muna kayo, no? So, hindi ko na rin masyadong